Hi all, welcome back to our YouTube channel. Topic that we will be having look at today is from FRM level 1 and it's from paper 2, that is quantitative analysis, and it's from chapter fundamentals of probability, and the topic is Bayes rule. Before we go ahead, please do subscribe to our channel, like and share with your friends who are preparing for FRM exam. So let's have a look at the question. So we have been asked, we will be given some information. So this is the information that we are given, and we have been asked to calculate in first part of the question unconditional probability of something, and in second question it's conditional probability. So because if you notice that word is it's given. So if something is already happened, so it says given, and these are the options. So the situation is like you have been given probability of unconditional probability of train arriving on time is 65%. So it goes without saying that train not arriving on time has a probability of 35% because either train will come on time or it will not come on time. So like it's a complement of 65%. So that's 35% of the time the train doesn't come on the time. So this is one thing, and based on that we have been given some conditional probability. So like if the train is on time, employee reaches to office, so that has a probability of 62%. And if train is not on time, still employee reaches on time, that has a probability of 47%. So this is the information that we have been given, and we have been asked to calculate unconditional probability of reaching the office. So that is probability of O if I consider these notations. And what is the probability that train arrived on time given employee reached on time? So we have been asked to calculate probability of T, that is train arrived on time. We already know that. So right hand side of the forward slash is something that indicates the event that has already occurred. So we know in the second question, we have been told that employee has already reached office. What is the probability that train was on time? Because if you notice over here, employee can reach office even if train is not on time. So that's what we have been asked to calculate. So let's see. So I just put in a divider. On the right hand side of this divider, we will do calculations. And on the left hand side of this board, we'll put given information in the format that is easily understandable to you. So binomial tree of the given information. So these types of questions are very easy if you plot binomial tree from the given information, because if you directly try to apply formula, that there is a very good scope that you can get confused. So let's put this given information in the binomial tree format. So as we saw, there was a train given in the question. So just a diagram or the icon of the train. So as we saw that it's 65% of the time this train is on time, and by by default it's we can conclude that 35% of the time train is not on the time. So 65% and 35% initially. So we were given that if train is on time, there is a probability of 62% that employee will reach office. So this is a conditional probability on this higher node. If we already know that train was on time, so this, as I said earlier, this right hand side of your forward slash will indicate event that all has already occurred. So we know that train was already on time. What is the probability that employee will reach office? So that probability we are given is 62%. So at the same time, let's calculate the joint probability that the train was on time. And so basically this notation indicates and, which is like joint probability. So there is a difference between conditional and joint probability. Joint probability is a multiplication of your unconditional probability times your conditional probability. So let's see what's happening at a lower load. There is a chance that train was time, still employee did not reach to office. So if this probability that train is on time, employee reaches office is 62%. So complement of that is, when I say complement, it's 100% minus 62%, that is 38%. So 38% of the time train is on time, but employee doesn't reach office. Maybe there could be a various reasons, like train was on time, but still he got called from family due to some emergency, or he was newly college dropped out. He joins office and he's feeling like going to movie for with girlfriend, and he reaches late to the office. So there could be various reasons. So hypothetically, there are chances that train is on time, but still it doesn't reach office. So that probability we have been given is 38%. And similarly, if I calculate joint probability of uh, train is on time and employee doesn't reach office is like 65% times your 38%. So that is around 24.7%. And I have just deliberately kept it in red because it just to indicate that employee doesn't reach office. So let's see. So these were two upper notes wherein train was on time. Now let's see what's happening when train is not on time. Where is the initial probability of that is 35%. So let's see. So we were given that if even if the train was not on time, employee could reach office 47% of time. So maybe kind of superhero kind of person. Still, train was not on time. He could uh, make it reach on time to the office. So that probability is 47%. So the joint probability of train not being on time and employee reaches on time is around 16.45%. And if I go at a lower note, which is a quite valid, if train is on not time, you may not make office happen or you're late. So that's a valid reason. And so probability of that is around 18.55%. So one good way to validate if you have done everything properly till this stage is to add all these probabilities. It should add up to 1. If it is not, then you need to just check your calculations in this binomial tree. So this was the information that we were given in the question. Now we have been asked first to calculate what is the unconditional probability of reaching to the office. So it's just a pure probability of O. So if you notice very carefully, the green text boxes are the, the scenarios wherein employees reaching office. So the addition of these two green text boxes will give us the unconditional probability of employee reaching to office. So if we add these up, so it's at the first node, that is 40.3%, and at the third node it's 16.45%. If we add these up, it will give us 56.75%. And the second question is bit tricky, wherein you have been asked to calculate the probability of train being on time, given the employee has reached office. So over there, we need to apply this formula, probability of A given B. So in our case, it would be probability of train being on time, that is T, given O, that is employee reached to office. So that would be equal to joint probability of AB in this case over probability of B. So this is a joint probability. And if we explore this, or another way to write this formula is just inverse of this probability of B given A times probability of A over probability of B. So this is a bit tricky formula. I mean, if you plot your binomial tree, it could be a very easy thing for you. Otherwise, formula can be confusing at instances. That's why it is always recommended that you plot binomial tree and then calculate the given conditional probability. And in exam, mostly the condition is in your entire case, the probability of A given B will be given to you. And what you would be asked is probability of B given A. So in this case also, if you notice, most of the time we were given probability of O, that is employee reaching office, given train was on time. And in question, if you notice the inverse, that is probability of train being on time, given we already know that employee has always reached to office. So let's apply this formula. And this is something which we has asked. As I said, that usually questions are with a pattern like probability of O given T would be given to you, and you would be asked to calculate probability of T given O. So if I apply this formula over here and explore a bit, so probability of T over O we have already calculated. It's if you want to explore, you can just put in this formula like probable conditional probability of employee reaching office over like given we train was on time times you the unconditional probability of train being on time over probability of reaching office. So the only tricky part is like this is already given to you. So probability of O given T 62% times your unconditionally probability of train being on time is 65%. So 0.62 times 0.65, which we already calculated initially because we knew that it would be required. So it's 40.3%. And this is a tricky part. Only denominator part is tricky, wherein we already calculated this in one. So 0.65%, 0.56.75%. So sorry, 0.5675 or 56.75%. Either ways, it's one and same thing. So if we put these numbers in the fraction, this is a probability that we get. So 40.3% over 56.75%, it's around approximately 71%. So the unconditional probability of employee reaching office is 56.75%. And the second question was probability of train being on time given employee has already reached the office is around 71%. So these are the options. So let's see. So option one was correct for this question. Hope you like the video. If yes, please do share with your friends. If you got any doubts, please feel free to comment in the comment box. And yes, you might have noticed that we just try to stimulate your thought process, which can help you enhance your learning experience. And once again, a request, please do subscribe to our channel. Thank you for staying till the end of video. Stay connected with the channel. Thank you.